Okay, everybody. Yeah, again, my name's Herb Winters. The district manager for the SWCD here in Gillum County. Just introducing Gus. He's our consultant. Been helping us out on lots of different projects in the 30-mile watershed. 30-mile is one of, I think it might be the third or fourth conservation effectiveness partnership watershed. And so what that is, it's a partnership between OWEB, DEQ, ODA, NRCS, and ODF and W. And the point of the conservation effectiveness partnership is to look at everyone's investments in a particular area and kind of evaluate how effective everything went. Is there anything we can learn from it? And then ultimately produce some outreach materials for people for the state of Oregon. And so we're really excited that OWEB came to us to do a CEP in 30-mile, and Gus is going to talk about all the neat things that we're doing. So,
thank you, Herb.
yes.
Yeah, I'm Gus Wathen. I work with Anabranch Solutions, and today I'm going to talk about all the work that we have been doing. We meaning basically our team, Gillum SWCD, us at Anabranch, ODF and W, and now some Oregon State people are trickling into the mix. But what we've been doing for restoration and monitoring around 30-mile Creek. Don't know how to do the push the button. Just four?
Yeah.
Okay. 30-mile Creek originates in the John Day Highlands and drains out to the John Day around Cottonwood State Park, its mouth. In the winter and spring, it has continuous flow throughout all the main stem. That comes from rain and snow, but like many creeks in the John Day Basin, once the summer droughts come around, 30-mile goes subsurface for long stretches. 30-mile is also home to a threatened population of mid-Columbia steelhead, making those sections kind of costly. There's good rearing habitat, but also you have many miles of streams that do not function at all. 30-mile had very similar historic impacts to many streams in the Columbia River Basin. First, the fur trade came in, got all the beavers out of there. Then in the mid 20th century, there were some catastrophic floods that came through the whole region. The biggest of which was the Christmas flood of '64 that ripped down these canyons, causing massive incision events and stripping all the riparian areas bald, basically. 30-mile, it doesn't have a road down it, but it does have channelization from previous agricultural practices and a railroad that came down from the Kinzua timberlands. But there's also been some land management improvements that have taken place that need to be acknowledged. The Conservation Reserve Program conserved 22,000 acres. Then there's CREP that put in conservation over 70 miles of stream and over 1,000 acres around that stream. And then there was the conversion to the no-till practice, which left root structure up on these highlands, keeping that soil around and really dampened the magnitude of some of those flash floods that were coming through and causing this massive incision. So this progress was great at arresting some of these major impacts that were going on, but it kind of left 30-mile kind of forgotten about as a steelhead stream. Here we are in wheat country with a canyon that you don't really ever see the stream. And so it was kind of off the radar. Except for there were a couple folks, these little pipsqueaks, grew up down in these canyons, ranching, hunting, and fishing. And they recognized how special a place it was, that the ecological kind of capabilities, and specialness that these canyons held. Now, Herb and Roger and Nori have now grown up, and in their professional life have now become land stewards and advocates for these creeks around Gillum County. They recognize the potential that Thirtymile had or still has, and have worked hard to try to get attention brought to that. ODF and W started to poke around in Thirtymile in 2017. They established some juvenile steelhead monitoring for abundant sites, as well as doing some spawning surveys, and started to uncover some really interesting facts that they saw in certain sections, very high densities of fish with extremely rapid growth rates. Some of the fastest growth rates in the whole basin were going on. But at the same time, they saw a lot of habitat that looked like this, where it really offered very little in terms of the stuff that fish respond to: complexity, cover. They saw potential, but they also saw detriments. Now, as their monitoring program started to take shape, these studies started coming out of the Bridge Creek intensively monitored watershed, just up the river a little bit, where these correlations were being established between beaver mimicking structures, beaver dam activity, and then steelhead production, where as beaver started to take over a system and add this complexity to the system, then the survival and density increase. The conservation district here is a small office in county that has one of the lowest population densities in the state. And here resources and capacity are limited. But there's a culture here of being efficient, of working together, and really making the most of what is available. And Herb also worked with us on Bridge Creek and some of that watershed scale restoration. And so, you know, they thought that this type of restoration, this low-tech process-based restoration, watershed scale restoration, might be a good fit for 30-Mile Creek. And so, and I think it was the winter of 2018, we started having these conversations, scheming about what might be done and where we could start and what really expectations might be. So yes, we've gotten started with some restoration, but along those lines, there's a lot of watershed. And so we've developed some tools to help prioritization, trying to help with that first call of where we should start with this restoration. And then there's also the monitoring around this. We want to be realistic too, that we are just mimicking beavers or throwing sticks in the creek, and we really want to know, is that having an effect? One, what's the baseline? What are we working with now, and are we making any progress to some of those goals that are outlined in the Atlas and in the results chain model? And so that's what I'm going to talk to you about today. It's basically an accounting exercise to make sure that all of us can keep track of all the stuff that is going on. So the reason restoration is happening is that we've had these impacts to our riverscapes. When I say riverscape, I'm basically talking about the stream channel and the floodplain around it. That we've created these simple systems that are sensitive, that are impacted severely by droughts and or pressures that are put on there. And then we have degraded habitat. And what we want to do is to restore some resilience to these riverscapes, to create systems that are dynamic and complex and can withstand droughts and floods and fires. And So that's kind of the premise, and to get to those goals, we are using a low-tech process-based restoration approach. Essentially, that's trying to mimic the structures that beavers build or mimic large woody debris dams. This type of restoration can be done at scale. Instead of working on hundreds of meters, we're trying to work on tens of miles to get this stuff done. The first project that we did, and I say we, but really it's the John Day Basin contractors that were out there sweating their asses off in August of 2020, on the Wilson Smith project. That is high up, 23 miles up Thirtymile Creek. And that project is 4 miles long. The interesting component of that is that half of it is we knew was ephemeral, and then half of it we suspected was perennial, but we really hadn't done much poking around. And so in that section of stream, we installed 169 BDAs, 94 PALs, and it was dry for most of the building process. These guys didn't know what water was coming, what they were working with. And then it wasn't until December that water actually came. We had an interesting trip with Steph and Brent and Ian the following January, where we went and looked at that project, and they brought electrofisher to tickle some of these ponds, and we found rearing steelhead or Oromicus in this ephemeral section. You know, this is only a month after water arrived there. And so that was a pretty cool observation. Pond after pond, we either saw them in there or caught them, taking advantage of this newly opened up habitat. The second project we got to work on was the Sniption project. This is 1.7 miles of main stem 30-mile creek, just upstream from Sniption Canyon, where it dumps out, consisting of 68 BDAs and 42 PALs. Most of this project area is perennial, but as you can see from this picture here, it has very little riparian vegetation, pretty simplified system. Here's a little flyover. We're gonna see if it works. We're hoping it does. Yeah. And so this was afterwards. This was November. Roger, is that when we were out here? When I crashed the drone? Yeah, and so this is that same section of stream with a series of PALs and BDAs placed in there. That's Sniption. And then we also have implemented the upper 30-mile creek project. That's 5.9 miles of main stem 30-mile. This is directly upstream from that Wilson Smith project. So that then gives us 10 miles of stream that we have with restoration done. I should also mention too, that these guys are very deliberate about how they're getting this stuff done. They've got these systems fenced first and enrolled in prep. And so trying to give some of this restoration the best opportunity to actually work. So we got to tip our hats to these guys, Roger, really for getting the landowners on board for this. 5.9 miles, 221 BDAs, 102 PALs. Most of this is a canyon section, but this section here, Comstock Basin, represents the top section of this project area. And this is actually where we're going to go on our field trip. Here's a flyover Herb did last month to show kind of, as this system was running off, how these BDAs are functioning up in Comstock Basin. We're really excited about this project, and we'll be excited to go out and see what's happening. This particular reach, this stream incision was starting to happen and getting worse. And so we wanted to arrest that and also kind of flood as much of that inset floodplain as we could to create this sponge that could hopefully provide more water for longer, as we get into those summer droughts. Oh, this one just wants to keep going. Here we go. Okay, so here's a map of what we've done in green and blue, Wilson, Smith and green, those 4 miles, and then Sniption and upper 30 Mile in blue, those were done last year in 2020. Giving us about 12 miles of stream treated with at least the first phase of restoration. I should say we have phase 2 planned for Wilson Smith this summer. We're also going to be doing designs this summer for 8 miles of the middle 30 Mile. So by the time that is built next year, we'll have about 20 miles of stream with treatments done in 30 Mile alone. This is not even taking into account all the work that they're doing. When Hay Creek, 4 miles is already in, 14 miles is designed. Ferry Canyon, it's got 3.5 miles, North Fork Butte, 1 mile. So Herb and Roger and Nori, they're rabid about this stuff. There's also what, 26 miles you want to get designed this year? So
And just real quick on, just for 30 Mile, there's like 11 or 12 different private lands. Voluntarily.
yeah, all of this work, the restoration and all the monitoring around that is being done on private land, which demonstrates a really great working relationship with some of these landowners that these guys have been able to facilitate. And thanks to those landowners too. So there's 116 miles of main stem and tributary habitat in 30 Mile Creek. And when trying to decide where that restoration happens, that's a lot of miles to walk around. And so we did a project called the 30 Mile Restoration Prioritization Project, where we tried to leverage some existing LiDAR data to help us identify, maybe take that first call, where should we start working? So essentially how that works is taking the LiDAR data, taking the digital elevation models from those data, and then using this process called height above nearest drainage that our colleagues at North Arrow Research do to help detrend that. So then we have this flat surface that has elevations. And then basically we fill up the bathtub. You know, we see what's 0.5 meter above the lowest point in the channel, what's 1 meter above, what's 3 meters. And then that can help us easily define over a large scale, what's the valley bottom? What do we have to work with? And how far away from that valley bottom are we from capturing that as far as where the channel and where the active floodplain might get. There was also some manual work done to make sure that we took into account any infrastructure, houses, barns, bridges, or whatever. And so making sure we kind of cut that stuff out of there because nobody's going to want us to flood their stuff out. And essentially what we get is some polygons that look like this. The blue is 0.5 meter, green is meter, and then yellow is 3 meter. As far as how far away from recapturing that are we. That also helps set those expectations where blue could be short-term accessing for the active floodplain. Green might be medium term, 5 to 10 years, and it'd take a while, but 3 meters is maybe not out of the question. So then to kind of make that useful, we broke those into kilometer-long sections, ranked those as kind of a proportion of active versus potential, and then could plot that out across the whole drainage to see where those widths basically panned out. And that's really kind of the first cut. It doesn't you know, it's just taking that LiDAR data, trying to help us identify, ooh, maybe this, we should start poking around and let's go look at this section. So that's the prioritization that we have worked with Herb and Roger Nori on. So ODF&W has, I mentioned their juvenile steelhead monitoring for abundance, density, survival. Then there's spawning surveys that occur. They also have this smallmouth bass exclusion study. And then in conjunction with them, we do a base flow tracking survey. Oh, let me see if this plays. This is a cool video that Lindsay took. This was just a few weeks ago of some hogs down in the lower Thirtymile. So that's super cool to see. Those are steelhead, by the way. So since 2017, they've been doing these juvenile surveys. And essentially what they found is that that the steelhead like water. They do well. That their highest densities are in the perennial sections of streams. But that not all those perennial sections of stream are created equal. And they have kind of attributed that to the habitat that exists there. That down the lower perennial sections have much more to offer in terms of riparian cover, complexity that's going on down there, and things kind of peter out as they get higher. So habitat quality is something that they recognize as a limiting factor. For their spawning surveys, they've noticed a very similar pattern where most of the spawning occurs in the perennial sections, and that the highest density of spawning is in that better habitat. It peters out as you get higher up, but there's still spawning in these ephemeral sections. And so this is part of the conversation that we're having that maybe we can all have today about the function of these ephemeral streams, and how much of an onus we need to put into restoring the ephemeral sections, if that's even feasible, and what are the costs of that too? What are the things that you need to take into consideration? And so I'll touch on some of those, but I think that would be a great discussion that, if you have time for it, would be really cool, because everybody here probably deals with that. The bass exclusion project started in 2019, and that is really the first effort was to try to quantify if smallmouth bass coming up from the John Day are eating steelhead fry and par, and then also to see if that could be mitigated by this bass weir. This is, I think, phase one of that weir. So some results of that, this graph on the right comes from 9 fish, I believe it was in 2020, 9 bass, and they looked at their stomach contents and they saw that the majority of what they were eating were actually steelhead. Lindsay's done a great job of quantifying what that actually might mean, but she's way better with those numbers than I am. They eat them, so we know that. This box plot here on the right is before the densities of steelhead rearing at the mouth site. So it's very low. And then afterwards, below the weir, still similarly low densities, but above the weir, much higher densities. So not only do the bass eat them, but it has effect on their population. Now this is kind of evolving and involving some folks from Oregon State to really try to model this under different climatic scenarios and different restoration scenarios to really help us try to predict what might happen to these steelhead populations, how far up they might have an effect with those smallmouth bass presence, and how climate change might alter what we're seeing now. So also in conjunction with the tagging efforts that ODF&W do, they are kind enough to come up to the Wilson Smith site restoration site. And we have a mark recapture survey done each spring up there. This site, the tagging site kind of bridges that ephemeral to perennial transition. And so we'll go and tag those fish, do a mark recapture survey, tag them with pit tags, and then as waters recede to base flow in mid August, once that creek channel is full of snakes, then they send me down there to go and try to find all these pit tags. And so it's essentially taking a pit tag wand and going through downstream of where we start tagging all the way up through quite a bit above to where we tag to try to find some of these tags and determine if they're shed tags, meaning they're either shed from their bodies or those fish perished somewhere, or if they're still alive. And then taking GPS coordinates so we know where they were tagged and then where they ended up. The questions that we want to answer with that are really to try to help us better understand how these rearing steelhead are using ephemeral streams and what kind of movement patterns are going on. To be very clear, some of our tagging events, we're like rushing out there as the water is drying up, almost disappearing for those ephemeral sections. And so the time in between, that stream is essentially going dry in long portions or getting very low in other sections. And then also we would want to know, because this is a restoration site, because we're putting all these beaver dam analogs and persistent log structures in the stream, are we having effect on some of those movement patterns that this is a life history display of these fish that are rearing in 30-Mile Creek? And so what we've seen, this pie chart demonstrates the directional movement. We do see movement, and almost 90% of it is in upstream direction, which is pretty interesting, given that stream drying up, that those fish are still able to move upstream. And that some of those movements are quite long. This map here, I don't know if you guys, if I'm blocking it. Here's the line between ephemeral and perennial. Downstream, those fish were tagged there, and then some of them, all these movements are almost or well above a kilometer long of fish moving as the stream is drying up almost to non-existence and moving upstream to this perennial section, find refugia and kind of waiting out those long summer droughts. This little histogram demonstrates kind of the bins in which those movements happen. And so green was in 2020. We saw quite a few movements, long distances. 2020 was a rough year. And so when we came back in 2021 to tag, densities were much lower. We had a harder time tagging fish. But still, we were able to see some longer movements. Some of these fish had to navigate 10 BDAs, 5 pals to go, almost 700 meters. Last year was quite sad. When we went out to tag, there was great spring rains and there was plenty of water, but there were like no fish. We just tagged a handful of fish. But we're able to detect some of those fish, some of them still being live, and some of them, one of them actually, one moved over 1,000 meters. So that's a pretty interesting anecdote that we've got from there, just the amount of movement that's going on. That also corroborates what we'd seen in the fall when we first visited Wilson Smith, that they're repopulating these ephemeral zones and occupying and utilizing that habitat, spreading out the competition from just those perennial zones. And so, but we also want to know, like, what's up with the habitat? What's going on with it? What is the state of it? And how might restoration affect that? And so we've developed a number of different studies that really try to leverage the limited capacity that we have to get these things done, but answer the big questions that revolve around the 3 major components. for what we think drives the steelhead productivity, and that's just the biology, the hydrology, and the geomorphology. So as part of the Butte 30-mile grant, monitoring grant, we do surface flow surveys where, again, at that base flow time, mid-August, they send me down in the snake pits and to map out basically the wetted extent of these stream channels. We started out doing the Wilson Smith project, and then we have 8 miles of Butte Creek that we do as well, also snaky. So here are some maps here of over the past 3 years, what we've seen. In 30-mile Creek, which we thought half of that was perennial. 2020, only 20% of it stayed perennially wetted. We thought that was bad, but then we got to 2021 and only 5% of those 4 miles stayed wetted. 2022 was much better. 51% stayed wetted. We had that nice wet spring. We saw the same pattern on Butte Creek, but less drastic, where our lowest accounting was done in 2021. We also utilize OWEB's low-tech process-based restoration monitoring protocol to do structure and geomorphic feature surveys, where we walk through and try to assess these structures, count beaver or man-made structures, whether they be log jams or beaver dams, and map out that stream channel. I won't bore you too much with these, but this is intended to be a rapid survey done quickly over a long spatial extent. And the information that comes out of that helps us make some of these adaptive management decisions. And so we have like BDA integrity, where 41% are blown out or breached, indicating to us that function of those structures is now compromised, and it's time for phase 2. Some cool things have happened from that, but it's time to get back in there and keep shaking that system up. We also assess the elevational response and the lateral response. So is there scour and deposition going on elevationally or longitudinally? Is flow being spread out? And so we can assess that at each structure pretty rapidly to know if we're actually having some intended effects. Are we getting overbank flow? Are we getting sediment deposition? Are we scouring out? Are we eroding these incision trenches that we're trying to get at? Here's a little picture of just what I'm talking about. This is the ephemeral section from upper 30-mile, where we have lateral erosion of a stream bank, also scour pool formation below that, and then dispersal of sediments too. I think Roger last year saw some spawning steelhead up in that site, right next to one of these blown out BVAs. But as it blew out, it also mobilized that stream bed. That stream bed had been locked in place for a long time. All the sediments are just embedded with fines, or, it's very hard to mobilize that substrate. And so it was pretty cool to see active spawning on top of some of these recent deposits. We also wanted to do really a census for what was out there, and some of these important structural attributes that we determine are important for fish. So that's beaver dams, log jams, and pools. And so this winter we did a really rapid effort. We walked 44 miles of stream and just counted the stuff. This gives us good baseline data, and as restoration starts to unfold out through there, that'll give us a good baseline measure of some of these things that we feel are important, that fish will respond to. In conjunction with that, we have the remote riverscape survey, where we're leveraging this consumer grade drone imagery and drawing polygons on top of that, trying to map out the active channels, the active floodplains, the inactive floodplains, to give us another measure of just really the status of 30-mile Creek. And so this is kind of what it looks like as we're drawing on top of those drone acquired imagery. Right now, this is going on, hopefully, right this second, but, 54 miles, Herb's already flown. We're gonna try to fly another 90 this year. And we have people right now, sitting there drawing these polygons to help us put numbers behind what is the status at 30-Mile Creek right now. We do some water temperature surveys, kind of a longitudinal profile to just get a sense of what stream temperatures, how they behave in 30-Mile and Butte Creeks. We also use these because they're ephemeral and we space them throughout. We also use these to determine the timing at which streams have gone subsurface. And then we have some more kind of dedicated BDA temperature logger studies to look at microhabitat variability in and around BDAs of these water temperatures. These graphs here, I mean, this one up top is just basically a timeline of 2020 and 2021 to show when these loggers went dry. That demonstrates how rough 2021 was, and then the fact that the loggers went dry a month earlier than they did in 2020. We can look at the number of days those loggers went dry, and also the number of days that water temperatures exceeded 25 degrees Celsius, kind of a thermal threshold for steelhead and Olmicus. And then we have these study BDAs where we look at how, as the water levels recede, you can see this expansion of, spreading out the variability in water temperatures even around these BDAs, demonstrating that they do provide some microhabitat refugia where fish could, in the hottest part of the day, kind of hunker down and wait it out. Also going on Wilson Smith is the UAV implementation and effectiveness monitoring. This is happening across many projects that the partnership is involved with. And so it's more of this kind of tier 3, really in-depth drone look with a multispectral drone to look at vegetation, temperature mapping, and a really accurate point cloud for this RTK drone. Also starting off is this macroinvertebrate study. This is in conjunction with Oregon State, where we're trying to see what's on the menu for these fish and how does that differ between perennial and ephemeral sections of stream. And so that is just kind of getting underway, and Lindsay just forwarded me some correspondence from Joe, the fellow that's doing that, and he's super excited about what's coming out. He actually found a bunch of caddis and mayfly in these ephemeral sections, and they weren't just drifting down. They were like coming out of the benthos once there was water there. And then he sees a much broader assemblage of macroinvertebrates in these perennial sections, some studs. And so that demonstrates that not only are fish that there is importance of that ephemeral sections of stream. Just the other day, well, maybe it was in March, I was out on Butte Creek with Brooke from the Wheeler SWCD. We were standing there in a ephemeral section far away from the perennial section below this BDA. And then there are 4 little juvenile steelhead just foraging in the water column, picking stuff off the surface, all spread out across this BDA. And so that really demonstrates that even though these sections are sink at a certain amount of time, if fish get trapped there, or if they're spawning, if there's small fish that get stranded out there, that they are sink. But at the same time, these rearing juveniles are taking advantage of that opportunity. They're spreading out the competition across that, and then fortunately having to find their way back to these perennial zones when things are going high and dry. The hydrology study, that's happening too. So this is also in conjunction with OSU, Skylar Herzog. He's got his students working on this, but it's really trying to help us understand what drives the hydrology in 30-Mile Creek. What is basically how much water is coming down, and what's the sediment? How the sediment impacts that to help us know, on these ephemeral sections, how far down is that water? How much water would it take to raise that up? And is restoring perennial flow throughout even feasible, given the water regime that we had? And so yeah, that's just another way that we're trying to look at what's going on with 30-Mile Creek. And so really what we want to do is be realistic about things. There's a lot of factors that may go into how steelhead produce in this system, how it is ecologically beneficial to the landscape. And we want to one, understand how it's functioning now, and also how it's functioning as we're doing these 20 miles of stream restoration. And so yeah. Yeah, any questions about anything? Did I get all the aspects? Heard? Okay. Well, no, really it's, it is kind of have these thresholds, and, there's certainly some error in there, but basically if the way I have it is essentially as we're getting up to drying out season, if it, what did I have? If the stream exceeds 30 degrees, or if the difference between min and max is above, I think it's either 15 or 18, we kind of assume that that's when it's starting to get dry. So it's really looking at those thermographs and trying to see, okay, when is that time frame there? That's the quick and dirty way of how we're doing that. Yes, sir.
So, when you have the drying of the stream and migration of the fish to the, are those both adult and juvenile steelhead that are migrating?
No, it's just juveniles, or it could be resident adults. There's a fish that I've detected a number of years now that it was tagged pretty large, over 200 millimeters, and year after year, I'm finding it in the same pool. And so that, I think that there's a broad range of life history, certainly down by the mouth, you'd have a much larger kind of proportion of anadromous versus residing fish, but I think higher up that there is a residency component. I mean, it's kind of amazing. When we first went up there in 2020, like the size of some of these fish in this little creek, it's really mind blowing. So yeah, I think that there's a component of both, but most of those fish that we tag are, they're 2-year-old par, 1-year-old par.
I was curious about the smallmouth bass exclusion. How do you, bass aren't as good, the steelhead are able to jump over it, I'm guessing, but the bass can't.
Lynn, your neighbor's got that question.
Yeah, so our bass exclusion here allows for the it does block the oxygen. But we're not worried about those fish coming up. For most
I think just from our observations that with the thermal sections, that those fish are gonna stay there as long as they can, as long as it provides suitable habitat, as far as being in their thermal regime and having enough water. And I think as those water temperatures start to creep up, I bet that's when they start trying to go upstream to find their honey holes. Lindsay also had some interesting water temperature data from 2021. That terrible year was like primo down low that had maximum temperatures of 16 degrees Celsius. And so you have this area that is like perfect for rearing steelhead because of this hyporheic exchange that's coming in. That's how those perennial sections functioning. And so that then begs the question, if we put water up and it's sitting there baking in the Gillum County sun for all of July, what's that going to do to water temperatures? But at the same time, you contrast that with like that map I showed where 5% of the 4 miles of stream stayed dry. And so I think, you know, a large component of this is, I think we're realistic here with the restoration and thinking about, you know, we're not gods, you know, we're not making. But what we can do is make those conditions better. And so in ephemeral sections, if we can keep cows out so that woody riparian vegetation can come along and saturate that floodplain, and so that that riparian vegetation can have at least survive through into July, let that sun get a little bit lower, so that then you have some shading going on, especially in those perennial sections that don't have any shading. I think that's a big component. So, and that also sets the stage for eventually what we want to have happen is that we don't have those poor boys out there pounding posts in July and August, that the beavers take over. But right now, there's just not suitable habitat for them. There's not a food source. But if we can play the long game, let riparian vegetation take hold, and then we can hand the system over to the beavers. And that would be a long-term vision for Thirtymile Creek. Yes.
Yeah, so about that longer term vision, you had a pie graph that showed a significant amount of structures that blew out or, you know, were damaged, you know, something like 35% that persisted. And so the strategy you had mentioned doing phase 2 on the section that you've done previously, is it to go back in and retreat areas that have already been treated up until the time the habitat conditions are able to support beaver who would be doing this work on their own, and how much capacity is there to be able to treat, go back and retreat, like you're talking about, you know, dozens of miles of stream. And so as you treated things, the number of miles that have been treated is going to be, you know, up to here. Can you continually retreat that? How many years will you have to retreat that until the beaver come back? Like,
Sure.
What's like I can see the whole thing's starting, but how is it all going to continue and end?
Yeah, I think one, the site that we're phase 2 is happening this year. That was the John Day Basin contractors, their first attempt at really building a bunch of PDAs. And so I think we and they learned a lot of lessons. I mean, there's nothing to build with out there besides sagebrush. And so that was part of an issue. Whereas you have these sections that blow out because we have such small building material, how they are built to, you know, everything is a pilot project. You have to see how that system or how that section of the system responds. But really, you know, it is kind of based on where are we seeing gains? Where are we seeing that we're starting to move the needle? And where's efficient and smart to work? And so like with the second phase, there's sections where it's essentially acting like that key, where there's bedrock wall, and then there's the old railroad grade. Water has no chance to make it out onto a floodplain. And we've lost a lot of structure that they've reached some places. They did do a lot of small scour pools, which was kind of cool, but you know, that area, we're not going to go bang our heads against the wall and say, oh, we're going to take over the railroad grade. But upstream of there and downstream of there, we're activating multi-thread channels. And so really it's like assessing what's going on, where are we gaining, and how do we work with that to further enhance that. And I think that, you know, Herb's been really creative as far as the capacity goes of being able to identify these different funding streams to help with that for some of these projects that you guys at OWEB have initially funded, you know, you're rigorous. You want to know what's going on, and it has to be well defined, and you have to have a good design. There are other mechanisms in our CS where that rigor doesn't have to be in place, and so that Herb's identified that as a great mechanism to start with these phase 2s, to work with the gains we've had, take those lessons learned and really try to keep those processes that we're trying to kick off moving in the right direction. So that then one day you can kick back on his porch and just watch it all. Not having to do that. Yes, sir.
In the prioritization, you mentioned the greatest restoration potential, but I'm not sure I heard the settled on how you decided where to do your initial work. Was it areas where you felt that you could work with the greatest potential restoration potential, or areas where you felt you could create more of a learning versus?
Yeah, that prioritization is simply looking at the and really it's the gift. So what could we capture? But I think that is, that's just a part of the puzzle, and that's something that this hydrology study is really going to help us understand, because as you, many of you guys probably have seen this in your own streams, is that when you have these constriction points, you have less capacity for that valley to catch sediment. And so you'll often see perennial flow emerge in these canyon sections where it just doesn't have room. Whereas when you get this wide valley bottom with all this opportunity for sediment to settle out, especially when these high giant floods came through and just dump a bunch of sediment, it settles out in the wide valley. And so that is something where that isn't the, it's not the whatever silver, whatever. But it's not silver bullet. It's just a component of like understanding where you have wide valley bottoms or where your inset floodplain is maybe wide enough that you could get the most maximization of this type of restoration. But really it's, it also, that's just kind of, then you maybe get on that and say, okay, what are you dealing with here? What do we see here that we can work with? What are the detriments of things that might be part of it?
So going back to your initial question, I think you posed as a worth restoring governance. I think what I'm hearing from the presentations, if you understand technology and you play it along, I'm hearing the answer is yes. Is that match up with your research?
Yeah, I mean, I think that the verdict's still out. I mean, certainly by concept it is. And I think what really we want to see is what kind of responses that we get, both in the perennial section, because we're not just, we learned this the hard way when we went and did Bear Creek, that we did everything in the ephemeral section, and then those structures sit dry all year round. And so working in the perennial sections to really maximize the capacity that has to not only provide in-stream habitat, but to soak up that floodplain too. And then seeing if we can start to get that to migrate out, build out. So but that needs riparian vegetation, that needs floodplain activation, saturation, off-channel wetlands. And so I think that, really this is a big experiment. And part of the monitoring that we have going on is really trying to assess that. Are we actually having an effect? If some of these land use practices like keeping grazing off while we're trying to get a start of that riparian vegetation, can we get it to survive? And does some of that build out? Because the inner annual variability, I think, of how much water is available, that's pretty drastic. And it goes from 20 to 5 to 50%. So overcoming that is going to be, and it's out of the scope from just throwing some sticks in the food. But what our hope is that we can help kind of the available habitat separate a little bit from the annual precipitation. And so you see a little bit of a separation, and it's not just tracking so tight. That would be our goal by soaking up whatever sponge is available to cover that. So I know that's not the answer, but that is our hope, and we're also trying to be realistic. We want to know those things, that water temperatures are perfect for these fish, and it may be terrible for the fish if everything's running all year round. But we need to know if it's even feasible for that to happen. Can you make things, can you make that, not necessarily, it's not just on or off, you know, it's not running or not, but could you make it that expanse of that section expand a little bit more, opening up more habitat for fish to survive that terrible drought season. Sue?
So I was curious on those that you did tag, has it been long enough for you to identify and see that they're passing other arrays going out and down in that?
We haven't seen the fish that tagged in like the Wilson Smith yet. We do have really low numbers of fish we tagged up there, as I said. And I think we lost a lot of our tag in that year. The lower down reaches, we had pretty average survival to the rest of the basin of migrating fish. So that's good, but the jury is still out on the Wilson. We're kind of time from. Yeah, I think a lot of those Wilson Smith fish will outmigrate at age 2 to 4. And so we're about, 3 years out from our initial sampling. So we should start seeing them outmigrating if they're going to. But like I said, we keep a lot of those fish on residents. And occasionally adults sneak back there and then they'll spawn and then we'll get a wholesome fish back.
Yeah, that's why Roger and Nori and Herb used to go fishing up there as kids. They want to catch the big ones.
Yeah, the fish is out of it.
Yeah, yeah.
Very cool. Horses.
All right. Well, thank you guys. And I really look forward to like getting out on the street and we can go and take a look at some of this stuff and continue this conversation because it really, how you learn is through knowledge transfer. And so all of you guys that deal with many of these same questions, it'd be great to hear your observations. So, thank you.